Now, accuracy, just to introduce the topic in terms of definition, is made up of several things or several techniques. And the first one is what is defined as the systematic error. Now, you have, as you can see, an ideal point. Okay, and that ideal point is the actual real value. Okay, so it is the value that it happens out in the field. Now, through a series of electronics and mechanical interfaces, there's a type of error built into it, referred to as the systematic error. And that systematic error is really a function of how the machine is actually made, or sorry, how the sensor is made, how the sensor is installed, how it is actually put in the actual instrumentation, or the actual process. And it will give you a bias away from the actual value. Okay, so and that is that it will be high or low from a particular value. Now, in general cases, most of the errors from the real world, from the real value, is to one side. Now, it could be high, it could be low, it could be negative, it could be positive, but they're all based around that. Then you have this other term which indicates the spread of each value as you repeat it. So there is no change to the actual value, to the real value, but when you take the readings, you sample it, there's a spread of readings. And that is referred to as the repeatability, how close each system will be. Then that is then taken an average of and referred to as the random error. So when you actually completely take all of those into consideration, the concept of total error or the inaccuracy becomes an important thing. Okay, so the definitions are as you see here. If you are trying to make a system more accurate, then there are two specific processes by which you can actually do it. The first is that you get a more accurate system, the one with less repeatability. Okay, the one with greater repeatability, I should say, the one with less spread of repeatability. So you actually are making the readings tighter together. Then what you do is you can put a bias in there. In other words, you're bringing the total error towards the real error. Okay, and all of those are really done and checked via a term referred to in different aspects of verification and calibration. Now, verification, the generalized term is that you are verifying that what the reading is within certain accuracy limits. And calibration means that once you've done your verification, you make a physical change, and then the physical change to the system, you change the BIOS, you do various other things, and then you check it again. So that is what is referred to as calibration. There are some other concepts, and one is referred to as the range of operation and the budget. Now, the range of operation is referred to as how much the value needs to be, what the spread of the value needs to be, so that the machine or the sensor can accurately portray the value that you're actually trying to get. Now, the There are a couple of terms which I need to mention, and that is it is reliably within its operating range, and also that it is accurate within its operating range, which basically means that you've stated a particular accuracy level, and what you actually are reading is the value plus the error or minus the error, but that total value is within the operating range. Within the specified operating error limit, the accuracy. Okay. So another term is the budget, which tends to be one of the things that alter and affect the accuracy of the system. No matter what you are trying to achieve, you generally have to pay for the quality of your system, and the quality directly relates to the actual, or is affects the accuracy of the system.